Okay, so now we're going to go ahead and we're going to write our system as a matrix equation. And then we're going to go ahead and use Gauss-Jordan to solve. So what I mean by this is that you guys are going to go ahead and, well, we'll all do it together. And let me change this to black. There we go. We're going to go ahead and put it into a matrix. So start with that right now. And we've got -1, 1, -2, 2, -2, 3, -4, 5, 3, -4, 7, and -1. Now, that's just the regular augmented matrix. What I want to do is go ahead next to here. We're going to write it into the regular matrix form of AX equals B, because this is going to give you that visual of what you are solving for. So, let me fix this. So we've got -1, 1, -2, -2, 3, -4, and 3, -4, and 7. That's just our general left-hand side. And it'll be times x1, x2, x3 equals, and then what our answer is, 2, 5, and -1. When we go ahead and get it into reduced row form, which is just using Gauss-Jordan elimination, it's going to give us our answers where we get 1, 0, 0 equals something. That's going to tell us what our x1, x2, and x3 are. So now we're kind of going both ways. So let's go ahead and hop into this. First thing, I'm going to go ahead and change the signs in row 1. So I have a 1. So 1, -1, 2, and -2. Okay, next up, I need to get these zeros to go away. So I'm going to do, take care of row 2 first. So that's 2 row 1 plus row 2. Whoops. Plus row 2. Not 2 row. 1, -1, 2, -2. That's the same. The last one's the same. 3, -4, 7, -1. And now I get 0, 1, 0, and what is that? 2, -4, 1. Okay, so that's where I'm at. I just did 2 times my row 1, which then gave me 2, -2, 4, -4, and then added it. And then that's where I'm at. I'm going to go ahead, draw a little line, and move to the next piece. Now I need to get rid of that third row piece, turn that to a 0, the leading term. So I'm going to do -3 row 1 plus row 3 to get rid of that. So my row 1 and row 2 are the same. Hopefully by now you guys are kind of getting the feel for the process. It's definitely a very cyclical process that you see every time. Okay, so just a little bit of scratch work. That gives me a -3, +3, -6, +6, and I'm going to be adding that to 3, -4, 7, and -1. If you guys still have to do the scratch work, that's fine. As we get into bigger numbers, totally understandable. And 5. Okay, I'm going to erase that to keep my work neat. Now I need to go ahead and, let's see, change. I'm going to do row 2 plus row 3 to get rid of that -1 in that row 3. So 1, -1, 2, -2, 0, 1, 0, 1, which is nice that row 2 is completely done. It simplified in that first step for us. Okay, so that gives us 0, 0, 1, and 6. So it looks like rows 2 and 3 are completely finished. We just need to work with row 1 now. So what I'm going to do is I'm going to say we're going to do row 2 plus row 1 to make that go away. So row 2 is the same, 0, 1, 0, 1, Row 3 is the same. And then my row 1 is 1. Then negative 1 plus 1 is 0. 2 plus 0 is 2. And then I get a negative 1 when I add those together. Now I have one final step. Hallelujah. I know it seems long, but that's why there aren't that many problems, and quality over quantity on these for sure. So in order to get rid of that 2 in row 1, I need to go, let's see, negative 2 row 3 plus row 1. Yeah. Okay, so this stays the same. Now, negative 2 row 3, that just changes that to negative 2 and negative 12. Add them together, you get 1, 0, 0, negative 13. Now that you are here, you see that you get this identity matrix equals negative 13, 1, and 6, which means that x1, x2, and x3 in this case are negative 13, 1, and 6. If you were to do scalar multiplication from this left hand, this original matrix right here, and multiplied it using scalar multiplication by that, you would get 2, 5, and negative 1. So there's that cross connection into the identity matrix, reduced row echelon, scalar multiplication, all of that. So kind of see how it crosses through. We only have a couple more things left, but this is it for day 1. So make sure you're understanding everything.